In the last set of notes, we've looked at tangents, secants, and chords. In this case, we are looking at tangents, secants, chords, and arcs. So we've got some extra information thrown in. Now you'll find that these diagrams here resemble somewhat what we talked about in the last set of notes, but we're going to take them in a different direction and include the arcs that are created, not just the segment lengths. So here again, two theorems. First, if a tangent and a chord intersect at a point on a circle. So we've got our tangent line that touches the circle in one point, and we have the chord that intersects at the same point. If those two intersect at a point on the circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. So there are two angles formed by this chord and this tangent. We have one angle here, angle ABC, and we have another angle on the other side, angle ABD. Now what this theorem is saying is that in each case, the measure of the angle is equal to 1/2 of the measure of the intercepted arc. Now if you remember inscribed angles, an inscribed angle was any angle whose vertex was on the center and whose two sides were chords. This is resembling that in that we have a vertex on the circle and one side's a chord, but the other one's not. It's part of that tangent line. But the same relationship holds. The measure of the angle is 1/2 of the measure of the intercepted arc. So in this case, the measure of angle ABC is equal to 1/2 of the measure of its intercepted arc. And remember, the intercepted arc here would go from A all the way around to B. So the measure of arc AB. So the measure of the angle ABC is 1/2 of the measure of the intercepted arc. Likewise, as we look at this larger angle ABD, the measure of that angle is also 1/2 of the measure of its intercepted arc. Now, because this is an angle that's larger, we've got a major arc here from A all the way around to B. In this case, the major arc goes from A through point E and back to B. But in either form, the measure of the angle is 1/2 of the measure of the intercepted arc. All right, the next one. Theorem related to tangents and secants. If a tangent and a secant, two tangents, or two secants, intersect in the exterior of a circle, which is what we see in each of these, we have an exterior point, then the measure of the angle formed is 1/2 of the difference of the measures of the intercepted arcs. So here we're looking at determining the measure of this exterior angle in each case. So it's saying that the measure of the angle is 1/2 of the difference of the measures of the intercepted arcs. So in this case, we're no longer adding anything together. We're looking at a subtraction problem. So in terms of the notes that we did last time, when the two chords intersected inside the circle, then the measure of the angle was 1/2 of the sum of the measures of the two arcs. Here, when the angle is outside, it's 1/2 of the difference of the two intercepted arcs. So looking at this angle here, formed by the tangent and the secant, there are two intercepted arcs. We have this arc from A to D, and we have another arc from B to D. One of them is always going to be larger than the other. What this is saying in the theorem is that the measure of this angle is 1/2 of the difference between these two measures. So I'd take the measure of arc AD, subtract from it the measure of arc BD, and 1/2 of that would be equal to the measure of the angle. Now in terms of what that looks like in terms of an equation, the measure of angle ACD is equal to 1/2 of, and this is where we're going to do the subtraction problem, the measure of arc AD minus the measure of arc BD. The measure of the angle is half of the difference of the two intercepted arcs. Now, looking at the second diagram, here we have two tangent segments. And in this case, we need to add a point to our diagram. So we are going to add a point up here, and we're going to call it H. All right, so the two intercepted arcs in this case, we have one arc that goes from E through H all the way around to G. So we have this arc. We also have another arc, the minor arc, going from E to G. So in this case, we have, similarly to what we had back here, we have a difference of two arc measures, like what we had before. We took the larger arc measure minus the smaller one, and the measure of the angle is half of that difference. So in this particular case, for this diagram, that's going to mean that the measure of angle EFG equals half of the difference. And in this case, we have a major arc and a minor arc that gets subtracted. So the major arc, EHG, minus the minor arc, EG. So the difference of the two arc measures times a half. Notice that the relationship exists regardless of what size these two arcs are. Wherever the points are where the angle intersects the circle, you get a larger arc and you get a smaller arc. You're going to subtract them every time. Same type of thing exists here where we have two secants. Now in this case, we're only looking at the angles arcs inside the angle. So where our angle in this case is HKM, there are two arcs inside that angle. In the interior of that angle, we have this arc from H to M, and we have a smaller arc inside the angle from J to L. So there again, the same relationship exists. I'm going to determine the measure of the angle by taking half of the difference of these two arc measures. So the measure of angle JKL equals half of the difference of the two arcs. So in this case, the difference of the measure of arc HM minus the measure of the arc JL. Half of the difference to determine the measure of the angle. So when we have a tangent on a circle, the measure of the angle is half of the intercepted arc, just like it is for inscribed angles. And when we have a point outside the circle, then the measure of the angle outside the circle is half of the difference of the two arc measures. So with that in mind, we have some examples that we want to look at. In the diagrams, they are not drawn to scale as they were not drawn to scale before. Find the measure of angle ABC in each diagram. So the measure of angle ABC. Since ABC is an angle with its vertex on the center, the measure of the angle is half of the measure of the intercepted arc. So in this case, I don't know what the measure of this arc is, but I do know that this one has a measure of 78 degrees, which means since these two complete a full circle, if I take 360 minus 78, that's going to give me a value of 282. So this arc is 282 degrees. The measure of the angle is half of the intercepted arc. So the measure of angle ABC is half of 282, or 141 degrees in part A. Okay, in part B, now I see an angle that is in the exterior of the circle, which means the measure of that angle is equal to half of the difference between the two intercepted arcs. So one of the intercepted arcs is here from A to C, that's the larger one, that's 122 degrees. From that, we subtract the smaller intercepted arc, which is 48 degrees. So 122 minus 48 gives us a value of 74. We need half of that. So the measure of angle ABC in this case, 37 degrees. So when the angle has its vertex on the circle, the measure of the angle is half of the intercepted arc. When the angle has a measure outside the circle, it's half of the difference of the two intercepted arcs. All right, in number 2, we're looking at some problems that are a little more algebraic in nature involving our lovely variable x. So let's look at how that one's going to work. All right, in part A, I see an angle outside the circle, which means the measure of the angle is half of the difference of the two arcs. So in this case, the measure of the angle, 0.5x, is 1/2 of the difference of these two arcs. We take the larger arc minus the smaller one. So x plus 60 minus, now I have to be careful because I've got two terms here that both have to be subtracted. So I'm subtracting x and I'm subtracting 20. Most common mistake is that people will remember to subtract x, but will not remember to change that sign on the 20. All right, combine your like terms. X minus x is going to go away. 60 minus 20 gives us 40. So 0.5x equals 20. Now we've got a couple of options. I can multiply both sides by 2 to get rid of this 1/2, or I could divide both sides by 0.5. In either case, if I multiply by 2 here, it's going to 2 times 1/2 goes away. Multiply by 2 on the right, x equals 40. And there again, you can substitute those back in to make sure that your answer is correct. So here, if we substitute, half of 40 is 20. 40 plus 60 is 100. And 40 plus 20 is 60. So if we've done it correctly, the measure of the angle should be half of the difference. So the difference here is 40. Half of 40 is 20. So we've done it correctly. All right, in part B, we see two tangents, which means the circle is divided into a larger arc and a smaller arc. Now, in this case, we're told the larger arc has a measure of 262 degrees. So let's determine what the measure of the smaller arc would be. 360 minus 262 gives us a measure of 98 degrees. And we need that in order to do this subtraction problem that we had here. All right, so the measure of the angle equals half of the difference of the two arcs, larger minus smaller, the difference of 262 and 98. All right, so subtraction, take care of those parentheses. 262 minus 98 gives us a value of 164. Half of 164 is 82. Divide both sides by 2 and x becomes 41. Okay, so here again we can check that. The 262 minus 98 gives us 164. Half of 164 is 82. So 2 times 41 is also 82, which means it is correct. And that takes care of how we work with arcs formed by tangents and secants.